Physics, May-June 2014, Paper 12. Part 1. Question 1. The maximum theoretical power P of a wind turbine is given by this equation, where ρ is the density of air, A is the area swept by the turbine blades, V is the speed of the air, and K is a constant with no units. What is the value of N? So you can see this expression, P stands for power, K is a constant with no units, ρ stands for density, A for area, V for the speed, and N is the power of speed. We need to find the power of the speed. In order to do that, the first step is to make the speed as the subject. So keep V to the power N to one side, and the remaining expression or the quantities to the other side. So you get this expression V over N, kρ over A, kρA will be the denominator of P. Now power is energy over time. So I have written E over T. Now energy means it's the product of force into displacement. This T remains as the denominator. The next step is to convert all these quantities in their SI base unit. So force is the product of mass into acceleration. So you can see mass stands for kg, acceleration meter per second square. Displacement stands for meter. K, as they have mentioned, K is a constant with no units. No units. You can, there's nothing to do with K here. Rho, it's the density, which is mass over volume. Mass, volume means L to the power 3. So it is kg meter per cube. So this stands for the SI base unit of density. A is for area, so meter square. T, the SI unit of time, is second. Now, when we simplify this entire expression, we get the answer as meter cube per second cube. Again, simplifying it, you can get it as meter per second to the power cube. The SI unit or SI base unit of speed is meter per second. In place of N, we have 3. As a result, the value of N is 3. You can clearly see that's option C. Question number 2. What is the unit of resistance when expressed in SI base units? So now we have to get the SI base unit of resistance. As we know, resistance, it is the ratio of potential difference across current. It is V over I. Now, what is potential difference? It is the work done or energy transferred per unit charge. In order to make things simple, first we will find the SI base unit of PD, potential difference. So V stands for PD in this case is equal to work done per charge. Work done is the product of force into displacement. Charge is the product of current into time. Now force, it is the product of mass into acceleration. This D remains as it is. Now the unit of mass is kg. The SI unit of acceleration is meter per second square. For displacement, it's meter. The SI unit of current is ampere and the time is second. Now once we simplify, we get this as kg meter square, S to the power minus 3, A to the power minus 1. After this, we substitute this SI base unit of PD in this expression. So resistance is equal to the expression that we obtained, this one, divided by current. SI unit of current is ampere. When we simplify, we get kg meter square to the power minus 3, A to the power minus 2. you can clearly see that the answer for this question is option B. Question 3. A cathode ray oscilloscope, which is also known as CRO, abbreviated as CRO, is connected to an alternating voltage. The following trace is produced on the screen. So this is the trace produced by this alternating voltage. The oscilloscope time-based setting is 0.5 millisecond per centimeter. So you can clearly see here the x-axis, 1 centimeter corresponds to 0.5 milliseconds. So your horizontally it talks about time. And Y plate sensitivity is 2 volt per centimeter. Y plate, that is the x-axis. This 1 centimeter corresponds to 2 volt. What statement about the alternating voltage is correct? The first option states the amplitude is 3.5 centimeter. That is incorrect because here we are not talking about amplitude in terms of centimeter. Here we are talking about the volt in terms of amplitude. So it's not about amplitude. You need to talk about the voltage. So this is incorrect. Frequency is 0.5 kilohertz. In order to find the frequency, first we have to find the time period. So time period is equal to the number of divisions for one wave. So for example, this is one wave. You can see this whole thing is one wave. So this is one wave. So one wave take 4 centimeter into time base. The time base is 0.5 millisecond per centimeter. That means 1 centimeter corresponds to 0.5 millisecond. So 4 centimeter will correspond to 4 into 0.5, which is 2 milliseconds. So it is 2 into 10 to the power minus 3 seconds, which is the time period. Now frequency is the reciprocal of time period. So frequency is equal to 1 over time period, that is 1 into 2 into 10 to the power minus 3. It becomes 500 hertz. 500 hertz, if you convert it to kilohertz, it becomes 0.5 kilohertz. Now, as a result, you can see this answer is correct. Sorry about my ink. So you can see this answer is correct. We already know this is wrong. This is correct. Let's check. The period is 1 millisecond. No, it is 2 milliseconds. So this is wrong. The wavelength is 4 centimeter. Again, the x coordinate or the x-axis do not talk about displacement or distance. It talks about the time period, how much time per division per centimeter. So we cannot talk about wavelength here, so it's incorrect. Therefore, the correct answer for this question is option B. Question 4. The quantity y is to be determined by the equation as shown. Y is equal to product of px over q square. The percentage uncertainties in p, x, and q are shown. So these are the percentage uncertainty. So what does this mean by percentage uncertainty? So if you have p, the uncertainty of p divided by p, this is the fractional uncertainty. If you multiply by 100, you will get 6%. To make things simpler, I have made it as percentage uncertainty this way. Similarly, percentage uncertainty in X as 2%, percentage uncertainty in Q as 4%. What is the percentage uncertainty in Y? Now we need to know, in order to find the percentage uncertainty in product or quotient, we need to just add the fractional uncertainty. So for example, if you have Y is equal to AB over C, the fractional uncertainty is del Y over Y is equal to addition of or sum of the individual fractional uncertainty. So you have del A over A plus del B over B plus del C over C. Now, if you want to give this in terms of a percentage of fractional uncertainty, you can give it this way. Del Y% is equal to del A% plus del B% plus del C%. That means I'm multiplying each term by 100% to convert it into percentage. Now, in our case, we have Px over Q square. So we take the sum of the percentage fractional uncertainty. So del Y% is equal to del P% plus del X%. So I'm getting this one. Then del Q%. But you can see there is a 2. 2 stands for the power. The power should be multiplied with the percentage uncertainty. So that's why I have multiplied 2 here. Del P% stands for 6. Del X stands for 2. Plus 2 into del Q% stands for 4. When you simplify, we get 16%. As you can see, the answer is C. Question 5. A thermometer can be read to an accuracy of plus minus 0.5 degrees Celsius. This thermometer is used to measure the temperature rise from 40 degrees Celsius to 100 degrees Celsius. So there is a rise from 40 to 100. So the temperature has increased by 60 degrees, which is 100 minus 40 will give us 60 degrees. What is the percentage uncertainty in the measurement of the temperature rise? Now we need to know that here they're asking about temperature rise. That means they're asking us to find the difference in these temperature. Now the uncertainty rule is that if you have to sum up or to find the difference, then your uncertainty will always be added. So if you have Y is equal to A plus B, or A minus B, your uncertainty will be always the addition of both of their uncertainties. So in this case, our temperature rise is 60 degree, 100 minus 40, 60 degree. Now you will have uncertainty for 100, which is 0.5. Again, for 40, uncertainty is 0.5. So basically it is plus or minus. So we get plus or minus 1 degree Celsius. This is our uncertainty in temperature rise. Now to find the percentage in temperature rise, you take the temperature rise uncertainty divided by the temperature rise into 100%. So percentage of uncertainty is 1 degree divided by the temperature rise is 60 degree. Into 100, we get as 1.7%. You can see the answer is D. Question 6. A radio-controlled toy car traveled along a straight line for a time of 15 seconds. The variation t of the velocity v of the car is shown below. What is the average velocity of the toy car for the journey shown by the graph? The question says the time taken to travel a straight line is 15 seconds. This is a velocity time graph. They're asking us to find the average velocity. Now, to find the average velocity, the formula is average velocity is equal to displacement over time. Velocity means a vector quantity. You need to consider the magnitude of your speed as well as the direction of the travel. So both should be considered here. Now, when we take the area of the VT graph, area of VT graph, you will get displacement. Now, positive side, or if your values are positive, if your V is positive, then it's moving forward. Your V is negative when moving backwards. So when we consider the area here, 3.0 into 10. The displacement is 30 meters. So let's keep this as your starting reference point. The radio control car is moving by 30 meters. Now this is for the next 5 seconds. It's moving with a speed of 6. So 6 into 5, 30 meters. It's minus 30 because it's returning back by 30 meters. So it moved forward by 30 meters. It returned backwards by 30 meters. That means it has come back to its initial position. That means the displacement here is 0. 30 minus 30 is 0. So here displacement is 0 divided by the time is 15 seconds. So the average velocity here will be 0. You can see that the option is B. 2 train carriages, each of mass 5,000 kg, roll towards one another on a level track. One is traveling at 2.00 meter per second, the other one 1.00 meter per second. They collide and join together. So they are moving towards each other, then they collide and they move off together. What is the lost in kinetic energy during this collision? So first, let's consider the principle of conservation of momentum. The principle of conservation of momentum states if no external forces acts on a system, the total momentum of the system remains constant or is conserved. Remains constant when no external forces acts means the momentum before collision is equal to the momentum after collision. Now let's find the momentum before collision. Here again we have to consider moving towards the right as positive, moving towards the left as negative. So you can see this 5,000 kg is moving forward, positive side by 2. So momentum is mass into velocity. So 5,000 kg into 2.00. This one is moving in the opposite direction. So negative 5,000 kg into 1.00 meter per second. Momentum after collision. Once they collide, they're going to move off together. So we need to sum up their mass because they join as one system. So 5,000 plus 5,000, 10,000. Let me take V as my final velocity. Now we need to find the final velocity. So this becomes 5,000 into 10,000 V. So if I make V as the subject, I get 0.5 meter per second. So the final velocity of both carriages moving together after collision is 0.5 meter per second. The next step is to find the kinetic energy before collision and then after collision. So here, the kinetic energy before collision is found here. So before collision, you just need to add up the kinetic energy individually, half mv² for the first one, then half mv² for the second one. So half into mass plus v², that is 2², plus half into mass into the velocity square, 1². So when you simplify, you get 12,500 joule. Kinetic energy after collision, half mv², half. Both carriages joined together, their mass is 10,000 and the final velocity is 0.5. So whole square, we get 1,250 joule. So this is the kinetic energy after collision. To find the kinetic energy lost during the collision, you need to subtract 1,250 from 12,500. We get 11,250 joule. As you can see, the answer is option C. A resultant force causes a body to accelerate. What is equal to the resultant force? So resultant force, let's mention it as del F. The acceleration of the body per unit mass. Okay, so normally the resultant force, it's the product of mass into acceleration. Here they are saying acceleration of the body per unit mass. So they are saying resultant force is equal to acceleration per unit mass, which is incorrect. The change in kinetic energy of the body per unit time. So they are, in other words, they're saying energy over time, which is power, not the resultant force. So it's incorrect. The change in momentum of the body per unit time. Change in momentum per unit time. This is also the resultant force. This is coming from the Newton's second law of motion, represented in terms of momentum. So if you have force is equal to mass into acceleration, acceleration is nothing but the change in the velocity over time. When you simplify, it is the change in momentum over time. So this is how this definition arrived. This is correct. The change in velocity of the body per unit time. Velocity over time, that's acceleration. So that is not the resultant one. That's not the resultant force. Therefore, the answer for this question is option C. A ship of mass 8.4 into 10 to the power 7 kg is approaching a harbor with speed 16.4 meter per second. By using reverse thrust, it can maintain a constant total stopping force of 920,000 Newton. How long will it take to stop? So this is the mass of the ship. It's traveling from 16.4. If you have to reduce the speed to 0 meter per second, that means if you have to stop this, you need to provide a constant stopping force of 920,000. Here, you know, force is the change in momentum over time. Now, this force to stop should be equal to 920,000. So here, mass is 8.4 into 10 to the power 7. The velocity it's traveling is 16.4. Final velocity is going to be 0, so it has to move to 0. So change in momentum is just this value divided by time is equal to 920,000. Now, once we make time as the subject, we get 1,497.39 seconds. Since that's not there in this option, these are given in seconds, you can see A and B is not the answer. Now better to find this answer in minutes. So divide the second by 60, we get 25 minutes, which is option C. Therefore, the answer for this question is option C. Question 10. A tractor of mass 1000 kg is connected by a tow bar to a trailer of mass 1000 kg. So tractor is 1000 kg connected by a tow bar to a trailer which is also 1000 kg. The total resistance to motion has a constant value of 4000 Newton. So the resistive force is 4000 Newton. 1/4 of the resistance acts on the trailer. So 1/4 of 4000 is 1000. So 1000 Newton of resistive force acts on the trailer. When the tractor and trailer are moving along a horizontal ground at constant speed of 6 meters per second, what is the force exerted on the tractor by the tow bar? Now you have to observe this. This is a constant speed. Tractor and trailer, they are moving with constant speed. And they are also traveling on a horizontal ground. So what happened? They're moving at a constant speed on a straight road. So their resultant force is going to be 0. Why? Because their acceleration is 0. If their acceleration is 0, their resultant force is 0. If the resultant force is 0, then the forward force given by the trailer is equal to its resistance force, which is 1000 Newton. So in this case, 1000 Newton of forward force is given by the tractor to the trailer. Now, according to the Newton's third law, we will have the same amount of force, equal force in the opposite direction. So 1000 Newton of force given on the tractor by the tow bar. As a result, the answer is 1000 Newton, which is the option B. The explanation is written here. If you want to read it, you can pause and go through. So the answer for this question is B. If you find this video useful, like this video and subscribe to Learners Club and press the bell button to get notified with new videos. See you in the next video. Bye-bye.